Good morning. And we are winding it down because we only have, after today, we only have 2 more lessons to go for the year. So today we are going to discuss lessons 12.3 and 12.4, multiplying rational expressions and dividing rational expressions. So let's just go ahead and give you a little background. To multiply rational expressions, you can divide the common factors either before or after you multiply. What that means is, please remember, you can cancel before or after. Okay? So let's go ahead and let's take it nice and easy. So remember, you may have to factor things out. So let's go ahead and look at my first example. My first example here is 5ab cubed over 8c cubed times 16c cubed over 15a squared b. Are y'all with me? So what I went ahead and did is I'm giving you an extremely visual approach to the problem, because what I find in Algebra 1 students, more so than in Algebra 2 students, what happens is if you don't prime factor, I find that they make a lot of silly mistakes when they go ahead with the exponents. So I don't want there to be any question. We'll just get rid of all that extra stuff, and I'll stick an extra 2 in there. All right, here we go. Sorry about that. Here we are. So 5ab cubed is 5 times a times b times b times b over 8c cubed is 2 times 2 times 2 times c times c times c. Times 16c cubed is 4 2's and 3 c's. And 15a squared b is 3 times 5 times a times a times b. Now we're ready to go ahead and to cancel. So let's go ahead and see what they have in common. So let me just make a comment. Everybody look and listen. When you can cancel diagonally and up and down. You can't cancel a numerator with a numerator or a denominator with a denominator, but you can cancel up and down. It would be like if you were reducing 4 over 8. Of course you can cancel and reduce that to 1/2, or you can cancel on the diagonal. So I have a 5 here and a 5 here. I have an A here and an A here, and I have a B here and a B here. Are y'all with me? I usually start with the first fraction. It makes my life easy. Now let's look at the denominator. I have 3 2's, which cancel with 3 2's. I have 3 c's, which cancel with 3 c's. I highly recommend that you circle your leftovers. Otherwise, you're going to mess up. So then whatever is left in the numerator gets multiplied together. So what's left in the numerator? B times 2, or what? 2b squared. And in my denominator, what's left? Just 3 times a, or 3a. It's not much different than what we've been doing, except that we're just adding that multiplication feature. Okay, does anyone have a question on this example? Anyone have a question? Okay, let's look at our next example. Our next example is 3x squared y cubed over 23d squared times 46d to the 4th over 15xy. So let's go ahead. I'm going to have you guys prime factor it. Who can prime factor 3x squared y cubed for me? Go, read it out.
3x squared 3y cubed is
3 times x times x times y times y times y. Good job. So let's just go ahead and write that here. 3 times x times x times y times y times y. Who can prime factor the bottom for me? 23d squared. That's an easy one. 23 is prime number. Go.
23 times 2 times 3.
You got it. Who can prime factor 46d to the 4th for me? Go.
46
Nice. And 15xy would be what? Yes. Okay, now we are ready to cancel. Are you all with me? Yes? Okay. So let's see if we can cancel together and what we get. I have a 3. That's going goodbye. Hey, we don't want white. We want it pink. That was weird. Okay, the 3 and the 3. 1x and 1x. 1y and 1y. How about the 23s and 2d's? Yes? So that leaves me an x times y times 2 times d all over 5. Okay, now I made a little note over here and I said it's most correct to put the variables in A, B, C order. So I would have listed it as 2d squared x y squared over 5. Miss Urso, I wrote 2xy squared d squared over 5. Okay, I'll give it to you. You're learning in Algebra 2. It has to be in order. Does anybody have a question on this example? Does that make sense? Hello? Yes. Are you sure? Okay, let's pick it up a notch and go on to something a little bit more interesting. So here we go. Let's look at this problem. Let me get rid of some of my work here. All right, so this time I have x minus 5 over x times x squared over x squared minus 2x minus 15. So this is my original expression. Step number 2, I want to factor x squared and x squared minus 2x minus 15. So what multiplies to negative 15, guys, and adds to negative 2? If you know, raise your hand. Go ahead. Negative 5 and 3. So it's going to look like this. X minus 5 over x times x over x minus 5 times x plus 3. And now you're allowed to just cancel away. Simplify. All right. So we have an x minus 5 cancel with an x minus 5. 1x and 1x cancel, which leaves me as my answer x over x plus 3. Who can tell me why I can't cancel the x's? Why can I not cancel the x's? Because the x plus 3 is joined together by an addition sign, or we could say they're holding hands. Good job. Anybody have a question? Alrighty, let's try this one. A squared plus 7a plus 10 over a plus 1 times 3a plus 3 over a plus 2. And we'll just get rid of all of this noise. And let's factor the top. What multiplies to 10 and adds to 7, guys? Okay, how are you going to factor? Sorry. How are you going to factor 3a plus 3? It's going to factor as 3 times the quantity, a plus 1. So here we go. A plus 2 times a plus 5 over a plus 1 times 3 times the quantity, a plus 1 over a plus 2. And now we can just cancel away. If you can see what's going to cancel, how we're going to simplify this, please raise your hand at this time. Thank you. Can you help me? What am I going to cancel?
A plus 2 because that's how it's a weight, and then A plus 4 is a section.
which is going to leave me as a final answer 3 times the quantity A plus 5, or 3A plus 15. They're both correct. Most of the times, most books are going to want you to leave it in simplest form as 3 times A plus 5. And as soon as I say that, when we put answers up tomorrow, they'll write it as 3A plus 15. Do you understand that both are correct? Yes. Does anyone have a question? All right, let's move on to our next happy lesson, which would be 12.4. 12.4, dividing rational expressions. Dividing rational expressions, here are your simple rules. Change the division sign to a multiplication sign. Flip the second fraction. Factor each numerator and denominator. Simplify by having a canceling party. P-A-R-T-Y. Have a party. Are y'all with me? Yes? Hello? Okay, I'll let you write that down while I erase some of these things. You guys can see that, right? I froze it? Yes, good job. Most of the time, these problems kind of want to fall apart for you, just so you know. So here we go. Let's go ahead and see if we can take care of our first problem. Okay, so to divide rational expressions, it's just like dividing fractions, guys. Multiplying fractions, that's no problem. Top times top and bottom times bottom. Dividing fractions, that's easy too. Divide to multiply and flip it too. All right, so we have 5x squared over 7 divided by 10x cubed over 21. So the first thing I'm going to do is I'm going to do a rewrite. Just like you rewrite in English, I am going to rewrite now. So I'm going to rewrite it as 5x squared over 7 times 21 over 10x cubed. Is everyone with me? Now I'm going to prime factor. And now we're ready to cancel. Simplify. Who would like to help me? Thank you, in the back. Go.
So you cancel the 7.
Okay, let's start with the top.
So you cancel the 5 and both of the x's with the bottom diagonal.
Okay, good.
And then you cancel both of the 7s on the diagonal.
Okay, so that that's awesome. 3 over 2x. Pretty simple, yes, guys?
Yes.
You like that? Anybody have a question on example number 1? Okay, example number 2. N plus 1 over n plus 3 divided by 2n plus 2 over n plus 4. Here's your number 1 mistake people make. They forget to change the division to a multiplication. So we're going to do a rewrite as n plus 1 over n plus 3 times n plus 4 over, we can factor this as 2 times n plus 1. Do you all understand that? Yes? Pardon me. And now we are ready to cancel. And so the n plus 1's cancel, which leaves me n plus 4 in my numerator, all over 2 times n plus 3 in my denominator. Does anybody have a question on that example? Are you guys writing any of this down? You writing anything down? I don't know how you think you're going to do your homework if you don't write it down, guys. 5a plus 10 over a plus 5 divided by a plus 2. Okay. Step 1, I'm going to do a rewrite. Okay. Second thing is I'm going to factor the numerator here as 5 times the quantity, a plus 2. And now we're ready to cancel. What's going to cancel, guys? Yes, the a plus 2's cancel, which leaves me 5 times 1, or 5, all over a plus 5. Why can't I cancel out the 5? Because the a plus 5 is being joined together. Question, yes? I put the parentheses because let me tell you why it's going to help you. It's going to keep you from hacking the problem. So if there's an a plus 2, a minus 5, a plus 6, x minus 3, I keep it in parentheses. That keeps you from being tempted to cancel the 5s out. Okay? I think this might be the last one. M squared plus 3m plus 2 over 4 divided by m plus 2 over m plus 1. I always circle my division sign to help me remember. It's going to change to a multiplication and flip the second fraction. So let's look at m squared plus 3m plus 2. And let's remember that we need to factor that. It's an easy x factor. What multiplies to 2 and adds to 3? M plus 1. Good job. Times m plus 2. All over 4. Divide to multiply and flip it 2 times m plus 1 over m plus 2. And now I'm ready to cancel. Someone who maybe hasn't answered a question today and would like to. Does anyone see something that we're going to cancel? Yes. The m plus 2's cancel, which leaves you in your numerator m plus 1 times m plus 1 over 4, or most likely written as m plus 1 quantity squared over 4. Now, if you FOILed out m plus 1, that would also be correct. Let me just tell you, this is how I would prefer the answer. And on your test, it's for algebra honors, your test is all free response. Okay, so there's no multiple choice. For algebra 1, it's almost half and half. I think a little bit more multiple choice than free response. Does anybody have a question? Okay, so today we learned how to multiply and divide rational expressions. Please remember that multiplying and dividing rational expressions is no different. We use the same exact rules that we use when we multiply and divide fractions. Thanks for listening, and we look forward to 2 more lessons. Have a blessed day.